Hello, so welcome to this podcast about Spinnaker. So let me start by introducing myself. So I'm working as a cloud architect at nordcloud. So been working mainly with German and Austrian customers for the past year, and during that time I have been able to look quite closely into CI/CD pipelines, and this kind of presentation and a small demo is all about that. And I hope you get something new from this presentation. And the difficulty level of this is 200, so I'm keeping it like more on the high level and not go too deep into all the gritty details. But let's start. So software deployments in legacy IT. I think most of you are like familiar with this, and there are several problems with this, especially when you are on top of cloud. So these are typically slow in the sense that there are a lot of manual steps to be done, and they can be also fragile because when you are doing those manual steps, it's easy to make mistakes. So you might run some shell scripts or commands from CLI, and it's easy to make mistakes. And you normally you might have to reserve a time in calendar for these deployments. So let's say you deploy a new version of your company application, and you need to have like several parties to come together. So reserving this time for all the people, and it can be a hassle, and it can take time. So normally these are reserved like in weeks or months in advance, and yeah, they can be bureaucratic. So as you see, there can be a lot of emails like back and forth between stakeholders, and of course the operations people doing the deployments. So this is normally done in a like throw over the wall fashion. So developers prepare some software artifact, and operations people take that, and they do the actual deployment. So in this context, and especially on top of cloud, it's quite easy to see what's the need for CI/CD pipelines. So of course, the first reasoning for this is the automation. You are not doing any manual steps anymore, so the whole pipeline is automated all the way from like testing and packaging to artifact, all the way into the deployment and delivery side. So of course, normally on top of cloud, we deploy maybe to EC2 instances or auto-scaling groups, or we might deploy to Kubernetes. So those two, I would say, are the most common scenarios when operating on top of public cloud such as AWS. Yeah, the increased velocity comes from this automation. So of course, when you have automation in place and automated testing in the pipeline, you are able to deploy new versions of software even like several times a day, maybe like several times per hour. So, and it's not always like big version updates. It can be like small incremental changes that you can deploy into production with high confidence that everything will work as supposed, and nothing will break. So of course, the target is to have 100% uptime even during these deployments. So what comes out of this is basically a better developer experience. So the developers are able to see their changes right away in test staging and ultimately in production. and they get immediate feedback from tests, and this really makes the developer experience better, and they feel more involved with this whole process. But this is also more productive for operations team. So personally, I come originally from a sysadmin background, and I much prefer to do automation and building these pipelines nowadays rather than doing these manual steps that were needed in the old days. So I would say this in no way bypasses the ops team. So ops team's role will change from the manual stuff into the automation side, as it really should be on top of public cloud. So a little bit background how I got involved with Spinnaker. So this was a customer project here at nordcloud, which kind of started like 1 year ago in the fall of 2017. So the customer had an old deployment mechanism in use. So it was mainly a set of custom Lambda functions that orchestrated autoscaling group-based deployments that were created with CloudFormation and templates. So this was working relatively well, but the main problem was that the original developer had left the company. So they were kind of left with this old implementation that no one really knew too well. And the customer started to think that why maintain this custom setup when there are so many existing products and projects available. So both on the AWS side, the CodeStar products, and of course on the open source side, several projects. And this is actually where the customer ended. So they chose Spinnaker for this, and the main reason for this was multi-cloud support that Spinnaker provides. So this is quite unique with Spinnaker, that you are able to deploy even in the same pipeline to Azure, Google Cloud, and AWS. So Spinnaker is a little bit like Terraform for deployment pipelines. So and this was like a huge driver for the customer, and this is what they decided to go forward with. And yeah, the goal was to provide more visibility and control the developers. So the reasoning here was that they didn't really want developers to go into AWS console, because it can be quite intimidating, and there's a lot of information that's not really relevant. So with Spinnaker, you get a really easy to use web console where you can see the deployments happening and the pipelines running, and the status of the deployments. And yeah, and even though they currently have these autoscaling group-based deployments, they are thinking of transitioning into containers in the future, so Kubernetes basically. So they wanted to be sure that whatever they choose, it should support Kubernetes. So this is basically where I became involved with this customer, and it was an interesting journey, and I will tell you a little bit more about it. So the Spinnaker logo. So I think many of you have probably seen this. So in the cloud native computing foundation landscape, Spinnaker is actually now included. So I think that happened, was it earlier this year or even before? So let's talk a little bit about Spinnaker and its history. So this was originally kind of started by Netflix. So they had an old kind of deployment mechanism called Asgard, but they really kind of saw the need to rewrite that, and they started to work for this like 4 or 5 years ago, and and the solution was open sourced in 2015. So this is still a relatively new open source project, at least when you compare to this one to Jenkins. So Jenkins has been around from early 2000s, and yeah, but let's talk about that later and the comparison to Jenkins. And what's nice about Spinnaker is that it's implemented itself as a microservices with microservices. So you can easily deploy that into Kubernetes, for example, and that's what I'm personally running it in the demo setup, and actually customer also runs Spinnaker inside Kubernetes. But you can run it on top of EC2 if you want. So you don't have to provision Kubernetes. And so let's take a look at the cloud native computing foundation landscape. So this is just a small screenshot of the CI/CD box. So you see Spinnaker here on the bottom left, and like you see, there are a lot of options. So I'm not in any way saying that Spinnaker is the only tool in this space. So there are others too, and you should really look into these different options. So some of these are maybe more lightweight. For example, the GitLab runner. It's really a simple setup when you have GitLab running, and but I would say no other tools in this list kind of match Spinnaker, because Spinnaker is fully focused on the continuous delivery and deployment side. So this is what makes it quite unique. And the other thing that, for example, compared to Jenkins, is that you don't really need to install any plugins or modules. So Spinnaker comes out of the box with all integrations to different cloud providers and different systems. So you just have to configure the systems, and you can start using them. So here is a list of the supported providers. So this list is quite extensive, I would say. So all the major hyperscale public clouds are supported, and also if you are running OpenStack on premise, it's supported as well, and Kubernetes. I think this is what gains the most interest, and there has been a lot of work inside Spinnaker related to the Kubernetes support. So at first there was the version 1 Kubernetes provider in Spinnaker, but that's being replaced with the new Kubernetes version 2 provider. So this new version 2 provider is kind of fully based on the manifests in Kubernetes. So the old version 1 was really highly opinionated, so it tried to model the EC2 based deployments quite closely, and it was good, but you were not able to change too much things. So it used replica sets to deploy every new version of the application, and then it kind of made the switch to the new replica set. So that's how it works. So it's basically the same model as is used with auto-scaling groups. And of course, related to Docker, there is support for the version 2 registry. So how this works is that you can push a new Docker image to the registry. Normally you have a private registry, and this will trigger the pipeline in Spinnaker. So this is one nice way to trigger the pipeline. But let's take a look at the Spinnaker components. So these are like the internal components in Spinnaker that run under the hood, so to speak. So these are the microservices that I mentioned earlier. So deck is the browser-based UI. So I will show you the demo, and you will see what the deck looks like. And then there's Orca, which is kind of the internal orchestration engine. So this makes sure that all pipelines run as supposed, and it orchestrates all of this stuff under the hood. And then there's Igor. This provides integration with Jenkins, Travis CI, and so on. So the integration with Jenkins is quite good actually. So you can trigger you can trigger Spinnaker pipelines from Jenkins jobs, but you can also call Jenkins jobs from Spinnaker. So it's kind of two-way interaction. And then there is Gate, which is the API gateway. So this is like the Spinnaker API. So you could command Spinnaker entirely using this API gateway, so you wouldn't have to use the browser-based UI at all if you don't want. So this provides quite nice possibilities to interface with Spinnaker if you are if you want to make custom functionality and integrate with Spinnaker. Then there's Echo, which is the everything boost for notifications. So this is like integrations to Slack, for example. So most companies, I would say, use Slack nowadays, and it's nice that you can forward these notifications from Spinnaker into Slack and immediately see what's happening inside Spinnaker. So this is part of a concept called chat ops. And you can also implement chatbots in Slack that call Spinnaker. So if you want to, for example, start pipelines manually, that is entirely possible, and you can even pass parameters to the Spinnaker pipelines. Then there is Rosco, which is the image bakery. So you are wondering what does this exactly mean? Well, this is basically a front end to Packer. So Packer is really like deeply integrated into Spinnaker, and this Rosco acts as a front end for Packer. So this is actually what the customer that I have been working with is using quite heavily. So they have like custom Packer scripts for preparing the AMIs for the software deployments, and everything is done automatically in the pipeline. So in the pipeline, you can just bake a new AMI based on the new software artifact, and you can back that artifact inside the new AMI. So this is a lot like Kubernetes, where you build a new Docker image. Then we have Fiat, which is the authentication service. So by default, Spinnaker doesn't have authentication enabled, but you can enable that when you have an external identity provider. So SAML is one really common way to add authentication on front of Spinnaker. Then there is front 50. So of course, all this means that Spinnaker needs to hold some metadata itself. So this service kind of keeps track of that, and the metadata is actually persisted when you run this on top of AWS. It's persisted on top of S3 bucket. And the last one is Carventa. So if you have been following news this summer, you have noticed that this is kind of the latest addition into Spinnaker. So this provides standard deployments. So what this means in practice is that, for example, if you use Datadog, you can integrate the Datadog checks into Spinnaker pipelines and deployments. So you need to have like certain amount of Datadog monitors like passing, and only after that the deployment is considered successful, and only after that it will be taken into use. So this is really a nice feature. And here you can see a kind of high-level diagram how the different services integrate with each others. So in front we have the deck, and we have the gate, which is the API, and the other services mostly work in the background. And actually, the one service that we didn't mention in the previous slide is the cloud driver. So the cloud driver basically manages the cloud provider integrations. So for example, on top of AWS, it talks with the AWS APIs and interfaces with those. So it's hugely important, of course. And some concepts in here. So Spinnaker kind of has this own methodology and its own terms. And the top level one is, I would say, is the account. So on top of AWS, this matches to the AWS account. And if you are running Kubernetes, this kind of matches to a single set of credentials against your Kubernetes cluster. And the second level is the applications. So you normally, of course, have several applications in use, and this is kind of the Spinnaker internal abstractions for that. And under one application, you can have one or several clusters. So these are like different software components, and below that you have server groups. So when you use EC2 based deployments, this basically translates to an autoscaling group. So you can have several of these autoscaling groups, but only one is active. So the logic in this is that we can keep a few ones scaled down, so that if we ever need to roll back to the previous software version, we can easily do that through Spinnaker. So this is the concept of server group. And but the most interesting part, I would say, is the pipeline. So this is where the magic happens, so to speak. So we will look at this in the demo quite soon. And inside pipeline, we have normally several stages. So these stages can be like deployed to some account. They can be any kind of checks. They can be manual gates, and there are a lot of these different stages available. And these stages become visible in the Spinnaker when you configure a cloud provider. And of course, like mentioned earlier, normally you want to start the pipelines automatically, and for this the trigger is used. So the trigger can be like Jenkins job finishing. It can be like new image being pushed to a Docker registry, and there are a lot of other triggers as well. For example, Google PubSub message if you are using Google Cloud. So here, high-level picture of the terms. So here we can see two different applications, and when we look at the application number 2, we see 2 server groups inside one cluster, the cluster D. And when we look at the server groups closer, we can see that inside the AWS account, there's normally the ELB or ALB, and the firewall is normally just a security group or several security groups. And these server groups are the autoscaling groups if you use EC2-based deployments. And and those server groups form the cluster. And like you see in the colors here, this kind of implies that we are using blue-green deployments. So blue-green deployments, for example, work in the way that you deploy a new server group, and if everything looks good, you do the switch on the load balancer. So you switch traffic to the new server group, and this won't incur any downtime. So from the perspective of end user, everything works as supposed. And like I said, we can keep the old server group available if we need to roll back. So I would say blue-green deployments are one of the most popular way to do deployments in CI/CD pipelines. But there are actually a few other deployment types available. So let's start with the first one. The Highlander is a term that comes from the movie Highlander. And what does it do is that it kind of just replaces the old deployment with a new one. So the old one is immediately destroyed. So this is like the most basic one, and this is something that you probably want to use if you just start testing Spinnaker. So this is easy to understand. And the next one is red-black. So this is like Spinnaker term for green or for blue-green deployments. So I don't actually remember the history why they chose this red-black, but it really doesn't matter. It's basically the same as blue-green. And then the third one is custom deployment type. So I implemented one of these for the customers for a certain application. So with the custom deployment type, you can basically do anything. So you create a pipeline that acts as the deployment logic. So this provides a lot of flexibility to do things with your own way, rather than using these predefined deployment types. And the rolling red-black is experimental, so we won't go that any further. And the latest one is the canary. So I think this will be quite huge, and it has certain advantages, certain benefits, because you can really use like external advanced monitoring tools to validate whether the new deployment is good to go or not. And with the green or red-black deployments, it could be only like if ELB health checks pass, then we consider that the deployment is healthy. But of course, that might sometimes ignore certain lower level problems. The next one, templated pipelines. So of course, you don't want to create these pipelines or any configurations manually in Spinnaker UI. Of course, that's entirely possible, but normally, since it's 2018, you want to do everything as a code. So the good news here is that Spinnaker entirely supports templated pipelines. So these are written in YAML using a DSL Spinnaker specific language, and you can also use Jenkins to inside the YAML template. So if any guys there are familiar with Ansible, it's very much the same. So with Jenkins, you can implement programmatic logic in the templates. And how you apply these templates is that there is a CLI tool called ROER. So with this ROER, you can update these templated pipelines against the Spinnaker API. And this tool is normally used to create automation. So for example, if you update a templated pipeline in Git, then you have a CI job that will automatically apply those changes to Spinnaker. So using the ROER tool. So this is how it should be done. So no one should like manually use the ROER tool. And let's look at this high-level picture of how the pipeline templates and pipeline configurations work. So what you code in YAML is actually the pipeline template, and then you create separate pipeline configurations. So the logic behind this is that you can create one generic pipeline template and use that for many applications and many pipelines. So you don't have to duplicate any code. You just pass these pipeline configurations together with the pipeline template. And after this, you have the runnable pipeline. So when you have the runnable pipeline, that's when the pipeline actually appears in the Spinnaker UI, and that's when it becomes usable. Yeah, let's take a look at some installation options for Spinnaker. So if you want to get started really quickly, you can use the AWS Quick Start. So just Google this. And what this will do is that it will provision one EC2 instance with all the Spinnaker components running. And you are just able to connect directly into the Spinnaker UI to test this yourself. So this will take maybe a few minutes to go through. Although if you are using this, if you are using your personal account for this, just notice that the EC2 instance will be quite big. So don't forget it on the running state. Then there is a Helm chart. So if someone hasn't heard about Helm charts, those are like the Helm is like package manager for Kubernetes. So it's an easy way to provision and start applications on top of Kubernetes. So there is a Helm chart available of Spinnaker. So you can also use this if you have a Kubernetes cluster and you want to test Spinnaker. But the official installation option is the Halvard tool. So you can provision an EC2 management instance and use Halvard from that. But you can also run Halvard from container. So this is the recommended method and actually the only method if you really need help from the Spinnaker community and developers. So they really don't provide too much support if you are using the Helm chart installation or quick start installation. So the Halvard is really the way to go when you want to install Spinnaker. So a little bit more about the advantages, and this topic I also already mentioned on a couple of occasions. So Spinnaker it's tailor-made for multi-cloud CD. So inside one pipeline, you can deploy into Azure, Google Cloud, and AWS, and even Kubernetes. So the options here are quite limitless, and all this happens without any need for scripting or plugins. So this is like completely opposite to Jenkins, where you have like 1,400 different plugins, where you not always know how well everything is maintained. So I think this is really nice in this respect. And yeah, so you get a cool UI into cloud accounts and Kubernetes and deployment itself. And yeah, the visibility is nice and it's much better and much easier to see what's happening when you compare to going or logging into, for example, AWS account. And yeah, tight integration with Packer. So even though all the hype is behind containers right now, I would say a lot of companies are still using traditional EC2-based deployments. So you could really easily switch those to Spinnaker and kind of replace your old deployment mechanism. And when you are ready to move into containers, you can continue using the same tool. You just migrate migrate your setup into containers. So Spinnaker supports all of this. But I know that many of you are thinking, so what's wrong with Jenkins? So there are actually quite a lot blog postings about this topic, but a few big ones here. So Jenkins was really made before cloud became a thing. So like I said earlier, it originally really started in the early 2000s or maybe 2005. So there really were not the public clouds available that are available now, and no containers in the form that are available today. So of course containers have been around in like different forms for like maybe 20 years, but nothing like Docker and nothing like Kubernetes. So of course all of this support is available through plugins, but there are really a big bunch of plugins and functionality, especially in the cloud and Kubernetes related plugins is not that good. So let's take for as an example the AWS pipeline plugin. So it has a certain amount of really basic functionality. For example, you can deploy CloudFormers and templates, but nothing really compares to Spinnaker and what you can do with EC2 based deployments. So you can configure basically everything, and Spinnaker will orchestrate everything. So this is much more powerful. But of course, like always, there are some lessons to learn. And for me personally, working with this customer for the last winter season, one of the biggest learning was that you really have to have an open source mindset. So this is by no means a kind of ready-made product, and you will run into bugs and issues that you either have to troubleshoot yourself, or at least you should report those to GitHub. So, and you of course from the GitHub issues, you can look if other people have hit the same bugs and issues, and maybe you can get help that way. And Spinnaker also has a Slack with a few channels, and that's actually a really good place to ask for help. So this is definitely a positive thing, but you shouldn't expect a ready-made product with commercial support. Although there is a new company called Armory.io, so those guys kind of provide commercial support for Spinnaker, and you really should look those guys and the website Armory.io if you are interested in this kind of commercial support and maybe a managed Spinnaker. And the second thing is that you really should allocate enough time and resources. So don't underestimate the time that it will take to really learn Spinnaker inside and out. So you need definitely one person fully allocated for this for a certain amount of time, like let's say 1 month, to really get the hold of the software. And Armor has also a really good set of documentation. So this is almost like a shadow documentation to the Spinnaker project itself. So it has been really helpful to have both places for documentation available. So let's take a look at the demo next. So we will jump straight to the Spinnaker UI that I have open here. So I have few applications here, and this demo environment is something that I just put up on my personal AWS test account. I didn't spend too much time preparing for this because I want to just show the Spinnaker in action. So this is like the application view, and here under the infrastructure you can see kind of the main components. So these different clusters. So for this For this demo, I have WordPress here and the database, MySQL database for the WordPress. So basically, I have two clusters here, and under these clusters, I have server groups. So this is something that I explained to you a while ago, but now you can see it here in action. So, and I'm actually using the Kubernetes version 2 provider here. So I have an EKS cluster for this setup running. And yeah, then we have the load balancers and the firewalls. So I don't have nothing there, but you can configure security groups through Spinnaker if you want. So kind of depends on your use case. And but let's take a look at the pipelines. So I have one pipeline here, as you can see, and let's take a closer look. What does it look like when you configure it? So these are the different stages here with kind of round circle, and here we have the trigger. So this is how the pipeline gets started, and for the purpose of this demo, I have done an automated trigger based on GitHub. So whenever I push a change to GitHub repository, this pipeline will kick off. So yeah, this is integrated with my GitHub. And the next step I have here is the deployment of the MySQL, and the second one is the deployment of the WordPress. So I have the expected artifact in my GitHub repository under the directory manifests, and the name of the manifest itself is WordPress deployment.yaml, and it will just take this manifest and kind of apply that into production. And even about this warning, so this Kubernetes version 2 provider is still under active development. So it was in alpha state this summer, and I think it's now in beta state. But it will be generally available quite soon, if I remember correctly. So after that, it's definitely safe to use in production. And just for demonstration purpose, I added a manual gate here. So the manual gates are normally used, or they can be used before you deploy into production. So if you want to have a manual steps so that someone has to log into Spinnaker and click a button, you can do this. And of course, you can integrate this with a Slack bot if you want. So let's try to kick off this pipeline. So I'm going to switch to my GitHub repository, as you can see here. So I'm going to just show you really quickly what's in here. So these are taken from the Kubernetes official documentation. I just added a few things here, like a few annotations. So I want to have an extra security group here, and I want to have cross-zone load balancing, and also for the persistent volume, I added a claim here with this annotation. So basically, I want the persistent volume to use the GP2, so generic SSD backend. But otherwise, it's the same as in the Kubernetes documentation. And for the MySQL here, it's basically more or less the same. So use it persistent volume claim here, and this uses a deployment. So this is like a recommended way to deploy software on top of Kubernetes, to use the deployment object. And Yeah. So let's make some change here. For example, let's edit this file here in the GitHub, and let's update something. Let's update the image version, for example. So let's update to a latest MySQL version. And let's commit this change. All right. So let's go back into the Spinnaker pipeline. All right, it started running. So we can click this initial kind of the stage or the first stage, and we can see the details about this. And this will take a while to run. So we can look at the original YAML here if we want, and we kind of see everything that's happening here. So it's scaling the replica sets. So basically scaling down the old replica set and scaling up the new one. So this is actually the deployment object that is kind of orchestrating all this behind the scenes. And the next step was to deploy the workers, but there wasn't actually any changes into that. And this is what the manual gate looks like. So it's either continue or stop. So in real world production use, you might want to check something manually if you really want, although that's kind of against the CI/CD principles, but you can have that in place if your organization really wants this. So maybe not everyone is ready for this full automation. So let's just click continue here, and in real setup, this would have triggered deployment into the production. So let's take a look at if this works. So I actually have this open already here. So let's just verify everything still works. Yeah, it does. So this was like a really simple example of a Spinnaker pipeline and how the Spinnaker works. So let's take questions from the audience. So you can write in the chat, and I will answer your questions. Okay, so the first question was, is Spinnaker available as direct service in the general AWS account? So unfortunately not. So Spinnaker on top of AWS is something that you have to install yourself, either on top of EC2 or on top of EKS. So it's not available as a managed service at this point. And the second question is that how can the pipelines be stored as code? So those are basically YAML templates, and unfortunately I'm not able to show you the templates because I have only the customer templates here, and I don't have any created examples. But you normally store those into GitHub or GitLab or whatever Git setup you use. And like I said, you normally kind of automate those with the ROER tool. So when you update the YAML files which contain the pipelines, the changes will be automatically applied to Spinnaker pipelines. So for example, if you run GitLab, you could implement this using GitLab CI. That would be a really simple setup. All right, thank you for the questions, and thank you for participating. And it was good to show this, and I hope this kind of sparked some interest towards Spinnaker. So I'm kind of personally noticing that there is a lot of interest growing in this, and please look at this closer, and Again, thank you for your participation. Bye.